Hey all, we were discussing NCERT solutions of the chapter Some Basic Concepts of Chemistry. We have already discussed question number 1 to 13 in the previous videos. If you haven't watched it, please do watch it. Today's first question is question number 14, and this is a very easy question, and the question says, what is the SI unit of mass? This is a very direct question and I hope everyone already knows the answer, and the answer is SI unit of mass is nothing but kilogram, which can also be written as kg. So this is the answer for the first question, that is question number 14. Let's go ahead with the next question. Question number 15 says, match the following prefixes with their multiples. So we have like 5 prefixes such as micro, deca, mega, giga and femto, and some multiples given. So now we have to accurately match the prefixes with their multiples. On the right hand side, I have listed some of the important prefixes that we should be knowing in order to solve the common questions that we do in our chemistry. So the first one is femto, which is 10 power minus 15. Next is pico, 10 power minus 12. Nano, 10 power minus 9. Micro, 10 power minus 6. Milli, 10 power minus 3. Centi, 10 power minus 2. Deci, 10 power minus 1. Peta, 10 power 15. Tera, 10 power 12. Giga, 10 power 9. Mega, 10 power 6. Kilo, 10 power 3. Hecto, 10 power 2. And deca, 10 power 1. So these are some of the important prefixes that we will be using. So from this table, or if we have memorized this table, it will be very easy to solve this question. We can directly say that micro is 10 power minus 6 and deca is 10 power 1, that is 10, and mega is 10 power 6, giga is 10 power 9 and femto is 10 power minus 15. So that's the answer for the question number 15. Let's proceed with the next question. Question number 16 says, what do you mean by significant figures? So this is a descriptive question. We know that every experimental measurements that we take has certain amount of uncertainty associated with it. On the other hand, we always prefer to have accurate and precise measurements. So this uncertainty in the experimental or the calculated values is often indicated by mentioning these significant figures. So this is the purpose of significant figures. We can define the significant figures as the digits in a properly recorded measurement. That is, we follow a certain set of rules to detect these significant figures. Roughly, we can define significant figures as the digits in a properly recorded measurement are known as significant figures. I hope the idea of significant figures is clear. We'll be looking more deeply into this when we are solving problems of how to write a significant figure. Question number 17 says, a sample of drinking water was found to be severely contaminated with chloroform, which is CHCl3, supposed to be carcinogenic in nature. The level of contamination was 15 ppm, that is parts per million, by mass. First question is, express this in percent by mass. Second, determine the molality of chloroform in the water sample. From the question, we know that the level of contamination of chloroform is 15 ppm. ppm is parts per million, and we know that million is 10 power 6. So 15 ppm means 15 parts in million parts, 10 raised to 6 parts, that is million parts. So this is the idea of what 15 ppm is. Now we have to first calculate the mass percentage, that is the first question. So we can say 15 upon 10 power 6 into 100 gives us the mass percent, that is 15 parts of chloroform in million parts into 100 gives us the mass percentage, and this gives us an answer of 1.5 into 10 power minus 3 percentage. That is, if we have a sample of 100 gram, then it contains 1.5 into 10 power minus 3 gram of chloroform. That is the idea of percentage by mass. Now moving ahead with the next part of this question. In the next part, we are asked to calculate the molality. Remember that it is molality and not molarity. So here, to calculate the molality, let us first calculate the molar mass of CHCl3, that is chloroform, and in this question, this is the solute that we are talking about. So to calculate the molar mass, we know atomic mass of carbon, that is 12, plus atomic mass of hydrogen 1, plus, since there are 3 atoms of chlorine, we multiply 3 into atomic mass of chlorine, that is 35.5. So this is giving us a sum total of 119.5 gram per mole. So this is the molar mass of chloroform. Now, from the concept of mass percentage, we know that if we have 100 gram of sample, then it contains 1.5 into 10 power minus 3 gram of chloroform or the solute. Now, since it is the molality, we should calculate it for 1000 gram or 1 kilogram of sample. And this is 1.5 into 10 power minus 2 gram of chloroform. To do this, we have simply multiplied this into 10, and that gives us 1.5 into 10 raised to minus 2 gram of chloroform for 1000 gram of the sample or 1 kilogram of the sample. Now we know that molality is the number of moles of the solute upon 1000 gram or 1 kilogram of the solvent. We can say the number of moles as given mass by molar mass. So now let us calculate the molality. We have the amount of chloroform in 1000 gram of the sample as 1.5 into 10 power minus 2, which we have calculated, divided by the molar mass of chloroform. Again we have calculated it as 119.5 gram per mole. So we get the final answer to be 1.26 into 10 power minus 4 molal. Question number 18 says, express the following in scientific notation, and we have 5 numbers. Let us first understand what scientific notation means. We know that in chemistry, we are dealing with atoms and molecules, which are having extremely small masses. That means we are dealing with extremely large numbers. It is often difficult to write these numbers in paper. So we have developed this idea of scientific notation, wherein we are writing these numbers in the form of n into 10 power n, where this exponent n can be both positive and negative. And this n, capital letter N, which is the digit term, has numbers between 1.000 and 9.999. So this is the idea of how we write a scientific notation. Now let us try solving these problems. So the first question here is 0.0048. So here the digit term should be in between 1.000 and 9.999. So we can write that as 4.8 into 10 power. Since here we are shifting the decimal point towards the right side and we are shifting to 3 numbers, we can write it as 10 power minus 3. From this we can say that whenever we are shifting the decimal point towards the right side, we get a negative exponent, and whenever we are shifting the decimal point towards the left side, we get a positive exponent. And the number depends upon the number of places where this decimal is being shifted. To understand this more clearly, let us do more problems. Next question. Here we can write the digit term as 2.34 into, here we have the decimal point over here. So we are shifting it towards the left side. So we have a positive exponent and we are shifting 1, 2, 3, 4, 5. 5 places. So we can write it as 10 power 5. And in the third question, we can write the digit term as 8.008 into 10 power. Again, we are shifting the decimal towards the left side. So we have a positive exponent and we are shifting 1, 2, 3. 3 places. So we have 10 power 3. And this we can write it as 5.000 into 10 power. Here again we are shifting the decimal towards the left. So we have a positive exponent and we are shifting 2 places. So this is 10 power 2. And the last question, here it is already in the form of a scientific notation, that is the digit term 6.0, which is in between 1.00 and 9.999. So we can write this as 6.0012 into 10 power 0, because 10 power 0 is equal to 1. So this is same as this. So this is how we write the scientific notation. The only thing that we have to remember and be careful is about the exponent and the signs that we are allotting to the number. I hope the questions that we solved in this video is clear to everyone. If you have any doubts, you can comment in the comment section. Thank you for your time.